Hi guys. Okay, so this is trig substitution for integration, part 2. This page right here that you're looking at has the substitutions we're going to use. So you should, if you don't already have this summarized somewhere, you should stop the video and put this in your notes because you're going to want to easily determine what your trig substitutions are going to look like. And then we're going to do some examples. All right, so here we go. Example 1, write it down and do it with me. You have 1 over x squared, 1 divided by x squared times the square root of 9 minus x squared. So this is what you're looking for. You've got the square root and you've got 9 minus x squared. It doesn't fit our arc sign quite because of that x squared in front. So that's when you're going to want to use this trig substitution. And so what we have is a situation where you have a squared minus u squared. And so we're going to, this first substitution, you're going to let u equal a sine of theta. And then if you watch that first video, plugging in u equals a sine of theta here, you end up with, after it's simplified, a cosine of theta. So we're going to use those two trig substitutions. And actually, you know what, I'll go through and show where that a cosine of theta comes from. So if you put in place of x here, this, what it's equal to, so let me back up here. So we had the square root of 9 minus x squared, which is the same thing as 3 squared minus x squared. And then by your trig substitution, when you have this situation, your u will be a sine of theta, and that comes from that triangle. And so again, watch the first video if you want more information about that. And instead of u, we have an x. And instead of a, we have a 3. The a has been replaced with a 3 here. So x is going to equal 3 sine of theta. And then if we plug in to here, we have 9 minus, if I put in 3 sine of theta here, I get 3 sine theta, and it's squared, so we square both the 3 and the sine theta, which is the square root of 9 minus 9 sine squared theta. Factor out a 9, you get 9 times 1 minus sine squared theta, and sine squared theta is identical to cosine squared theta. That's a Pythagorean identity. Taking the square root of 9 and taking the square root of cosine squared, you end up with 3 cosine of theta. So our 3 squared, or 9 minus x squared, we can sub in 3 cosine theta. So we're using trig substitution to make the integrals easier to integrate. Just like when we do u substitution, we use u substitution to make the integral easier to integrate. So this is just going to take a little bit of practice, but it's the same kind of concept. All right, so replacing everything here, we have oops. All right. If we sub all that in, this becomes, let me do this over here. We have the 1. I'm not going to replace that with anything, but I do need to replace the x with 3 sine theta, and it's x squared, so I got to square the 3, and I have to square the sine. So I get 9 sine squared theta. That's just subbing in the x and then squaring it. And then 9 minus x squared, the square root of all that is 3 cosine of theta. So I'm going to replace this with 3 cosine theta. And then we have dx here that we need to replace with something in terms of theta, because our integrand is in terms of theta. We need our what we're integrating with respect to also be in terms of theta. So now what we need to do is figure out what dx is. So we have x here, so dx is equal to, we have a constant times a function, leave the constant, times the derivative of the function, we have dx is equivalent to 3 cosine theta d theta. So now I'm going to put that in for dx. So right here, I'm going to have 3 cosine theta d theta. And it's in the numerator. If you want to put it over 1, you can. But now if we simplify everything, the 3's cancel out, the cosine theta cancels out, and now we have our integrand is 1 over 9 sine squared theta d theta. Okay, so at this point, if you look at, we do not have a direct substitution for 1 over sine squared theta, but I can pull out a 1/9, and instead of writing 1 over sine squared theta, think of its reciprocal identity, which would be cosecant squared theta in the numerator, d theta, and we do have an antiderivative for cosecant squared theta, and hopefully you remember it is tangent. No, it isn't. Tangent is the antiderivative of secant squared. The antiderivative of cosecant squared is negative cotangent x, or theta here. So I need a negative out here if I'm going to, because there's no negative in the cosecant, so it would have to be negative 1/9 cotangent of theta plus c. Okay, and now we need to finish this problem up by replacing this back substitution. We got to figure out what cotangent theta is in terms of x. And if you recall, cotangent of theta is equal to cosine of theta over sine of theta. And we know that we have this right here, that x equals 3 sine of theta. So if we solve that for sine of theta, because we're going to substitute our sine of theta in terms of x, so if you solve that, you get sine of theta is equal to x divided by 3. And likewise, our cosine, we got to figure out what cosine is, and we had this right here that, where is it? 3 cosine theta, oops, we have 3 cosine of theta equals the square root of 9 minus x squared. So square root of 9 minus x squared was equal to 3 cosine theta, and solving that for cosine, we end up with cosine of theta equals the square root of 9 minus x squared over 3. So then, if we want to replace cotangent with what it is in terms of x, we're going to have our cosine divided by our sine. So this is going to become, back to my purple here, negative 1/9 times cosine over sine, so the square root of 9 minus x squared, over 3, that's my cosine right here, and then divided by sine, which is x over 3. So remember how to divide, we're going to flip and multiply, so we keep that negative 1/9, and then we have the square root of 9 minus x squared over 3, and we're going to multiply by the reciprocal of the denominator, which is 3 over x. Those 3's cancel out, and so your final answer is negative 1/9 times 9 minus x squared, square root of that, over x plus c. That is the integral, evaluating the indefinite integral that we started with way back up here. So, example 1. Go back, watch it again, write the steps down as you're going through it, and I will do some more videos with some more examples, but that's it for this one.